This question is based on photoelectric effect. So there is a metal surface. Initially, it is illuminated with a wavelength lambda, and the stopping potential is 8 volt. Then it is illuminated with the wavelength 3 lambda. Now the stopping potential is 2 volt, and we need to find the threshold wavelength lambda 0. So in photoelectric effect, we can use the photoelectric effect equation, which is based on conservation of energy. So incident energy of the photon will be utilized in two ways. One is to take the electron out of the metal surface, which is known as work function phi, and then the kinetic energy of that particular electron. So you can think that there is a metal, we are shining a light, which means we are giving some energy in terms of photons. Because of that, the electron is going to come out. To take the electron, we have to spend some energy, that is work function. Once the electron is coming out, then it will move with some kinetic energy. So overall, this is going to be the final kinetic energy or the final energy. So incident energy, which is energy of the photon, is equal to final energy, which is work function plus kinetic energy of the electron. Here, the kinetic energy of the electron can be equated to stopping potential E into V0. Okay, so the equation is getting changed. E equal to pi plus E into V0. V0 is the stopping potential. Now, let's rearrange this one. E into V0 can be written as E minus phi. So this incident energy of a photon, we can write it as hc by lambda. Similarly, the work function, we can write it as hc by lambda 0. Lambda 0 is the cutoff wavelength. So let's write this equation for each case. For the first case, the incident energy is lambda and the stopping potential is, I think, 8 volt. Let me look. Yeah, 8 volt. So E into 8 volt equal to hc by lambda minus hc by lambda 0. So from, okay, let it be there. Let's write for the second case. In this case, it has 2 volt. E into 2 volt equal to hc by 3 lambda, because incident wavelength is 3 lambda. And the work function is going to remain constant because it depends on the material. So the metal is same, the work function should be same. Since we need to find the lambda 0, and we'll try to rearrange this equation and figure out. So from this, I just want to write electron volt on the left side. It is going to be 1 by 8 into hc by lambda minus hc by lambda 0. Let it be equation 1. And similarly, I want to write electron volt here, which will be 1 by 2 into hc by 3 lambda minus hc by lambda 0. So if you look at the two equations, left side is same, which means the right side should also be same. So 1 equal to 2. Let me write here 1 by 8 into hc by lambda minus hc by lambda 0, which is equal to 1 by 2 into hc by 3 lambda minus hc by lambda 0. So this will become 4. This we can cancel, and this hc terms we can cancel. So we left with 1 by 4 lambda minus 1 by 4 lambda 0, which is equal to 1 by 3 lambda minus 1 by lambda 0. Let's bring lambda 0 terms one side and lambda terms another side. We will get 1 by lambda 0 minus 1 by 4 lambda 0 equal to 1 by 3 lambda minus 1 by 4 lambda, and this is going to be 3 by 4 lambda 0 equal to, I think this is 12 lambda 1. From this we can write lambda 0, which is equal to 9 lambda. So here the cutoff wavelength our threshold wavelength is 9 lambda.